Okay, so we're doing rational exponents with variables. So we're still kind of dealing with a lot of the stuff we were dealing with yesterday, but we're adding some variables in there, some letters. So I want you to realize the product rule, we actually went over problems with the product rule and the quotient rule yesterday, number 26 and number 27. They had, remember where as long as they had the same root, we let them combine underneath the house and simplify? Do you remember that? Okay, if you don't remember, we'll look at it in a second. So just know that if they have the same root, you can combine them underneath that house. Okay, again, if you're dividing and they have the same root, you can combine them underneath the radical. Okay, this is just from yesterday, just a reminder. Okay, and this is the new one today. If you notice, there's multiple radicals with different roots. Yes? Okay, so I want you to realize something. Does order matter when multiplying? No. So if I rewrote this n times m to the a, or not to the a, but the root a, did I change anything mathematically? No. So then if that's true, then can I rewrite it also like that? Yeah, so I want you to see that you can change the order of your roots if it benefits you to simplify your problem. So we are going to do an example, so don't freak out. But I just wanted you to see that mathematically it's allowed because the rule is to multiply, and order doesn't matter when multiplying. Okay? So we have 4 examples, and then I'm going to do one of them on the practice with you just because it's been a while. And then y'all are going to practice. Okay, so if we look at number 1, number 1's a lot like yesterday. Now, this is power to a power because we have parentheses and we have a power on the outside, right? What is the power of 256? 16. If there's no, that's the x's power. 1. If there's no power, can't we put a 1 there? Okay, so this is 256 to the first power, x to the 16th power. And remember, we have to multiply the 3/4 times all the powers on the inside. So what's 3/4 times 1? 3/4. And what's 3/4 times 16? Well, you can use your calculator. Remember, when multiplying fractions, y'all, 16 over 1 times 3 over 4. Well, 16 times 3 is 48. 1 over 4 is 4. What's 48 divided by 4? 12. Okay. So knowing this, we can simplify this. This is just like a problem from yesterday. So we're going to do the 4th root. Remember, the bottom number is your root to the 3rd power. What to the 4th power gives us 256? 4. Okay, and remember the 4th root cancels the 4th power. And we get 4 to the 3rd power times x to the 12th power. So how can I simplify that? We can't simplify x to the 12th, but can we simplify 4 to the 3rd? So we get 64x to the 12th power. Yep. Okay. You good? Okay. Okay, so let's look at number 2. Now, number 2 is kind of like one of the problems we did yesterday. Again, this is going to follow that quotient rule up top. Are they the same? Are they both cube roots? Yes, therefore we can rewrite it under a single cube root. And we can simplify because none of that is a perfect cube. Well, kind of, but the numbers aren't. So we can do 81 divided by 3, which is 27. Now, where are there more m's, top or bottom? So we have m on top, and what's 4 minus 1? Okay, and does anything simplify with the n? So I'm just going to bring it down. Now, I no longer have a denominator because we simplified and there's nothing left down there. And now, we need things that are cubed to cancel our cube root, right? So I want you to realize that there's kind of three pieces. We have a number and we have two letters. So I'm going to find three things cubed. What cubed gives you 27? Now m cubed gives you m cubed. But what about n to the 12th power? We've done this before. It's been a while.
And 4.
You're exactly right. Because this is power to a power. 4 times 3 is 12. So did I change anything mathematically? No. So this cube root cancels all the cubes. And we're left with 3m n to the 4th. Any questions with that? You don't like it. You love it. There's a difference. Y'all are very nice. Okay. 81 divided by 3. Yeah. Okay, let's look at number 3. So, yes, we could follow the rule that we just learned, the power rule, where we multiply all of the things, but 3 times 4, well, what is that one? What kind of root is that? Square root. If there's no number, remember it's just square. So 3 times 4 times 2 gives you 24. Y'all, we don't need that big of a root. So let's just take it one piece at a time if we can. Is 256 a perfect square?
Yes.
Yeah. So we're going to rewrite this. I have 3, 4 squared. 16 squared equals 256. So I haven't changed anything mathematically. So this square root cancels that squared. And I'm left with just 16. Now, can 16 be written as something to the 4th power?
Yes.
What? 2 to the 4th power. So this cancels that, and I'm left with the cube root of 2. Can that simplify? Nope. Okay, now if you look at number 4, is 36 a perfect cube? Cube. No, it's not a perfect cube. But remember, we talked about that rule and how they can interchange and switch places. So can we flip this? Yeah, and we can rewrite it as cube root square root 36. Well, what's the square root of 36?
6.
Yeah, so we still have the cube root, and if I leave that there, it's because 6 squared, remember, it's just 36. This cancels that, and we get the cube root of 6. Can that simplify at all? It's not. So I do want to look at one of the practices with you. It's something that you've done before, but we haven't done it in a while. You remember when we were simplifying radicals? Like we were simplifying square roots? We were doing the factor tree and stuff? Okay, I don't even remember when we did that, but we did it. Promise. Okay, so look at number 7 on your practice. You know, whatever. I'm just kidding. Okay, so how can I rewrite this? What does to the 1/2 power mean? Well, the 1 doesn't change anything. What about the 2 on the bottom? It's a square root. Right? Because this is a square root. That's where the 2, remember the bottom number is your root. And the top number is your power. Well, power of 1 doesn't change anything, so we're good. But I can't combine these. When adding or subtracting, you have to have the exact same root with the exact same base on the inside. Well, they're not the same. It does. But you have to break them down first. So those are not perfect squares, but we can simplify the radicals. So the square root of 75, well, 5 goes into 75 how many times? 15. And 5 goes into 15 3 times. That's all 3 prime. I made my prime factor tree. And since I'm doing the square root, square is what number? 2. Here's 2 that match. We take it out. And what's left over? So we just simplified that radical. Now let's try 108. 2 goes into 108 how many times? 2 goes into 54 how many times?
27.
Now 2 does not go into 27. Does 3?
Yes.
Yes. How many times? 9. And then 3 and 3. So remember, because this is square root, I'm looking for pairs. Here's a pair of 2's that gets to come out, and a pair of 3's, and a leftover 3. Well, what's 2 times 3? Now, do they both have a square root with a 3 on the inside? Therefore, now we can combine them. So what is 5 square root of 3 plus 6 square root of 3? 2 times 3. You multiply them. No, just the outside number. So it's 11 square root of 3. When adding or subtracting, you're almost treating the radical with the number on the inside almost like a variable. They have to match.
So it wouldn't be 2 times 2 is 4 and then
No, because remember, so this is why. Watch. This I can rewrite 2 squared times 3 squared times 3. So if I took the square root of that, well, the squared and that are canceled, but that 3 is still left on the inside. Well, 2 times 3 is 6 square root of 3. Remember, the square root cancels that double. It's so we can combine them because they have to have alike radicals. Now, one thing I do want to show you, we will talk more about this later, so if it totally throws you off, don't stress out. 108, I'm going to break it down again just the way we did. So I didn't change anything, I just repeated the factor tree. But what if I was trying to do the cube root of 108? So a square root, I needed a pair of 2, right? So a cube root, do I have 3 3's? So I could take a 3 out, but could I take a 2 out? So what's 2 times 2?
4.
So you can simplify any radical with any root, but that's just how many pairs does you see what I'm saying? Because it's cubed, you needed a group of 3. Because this was square root, which has a 2, you needed a pair of 2 to take it out. Okay? Okay, so y'all are working